So this is the third of the binomial distribution videos, and we've looked at what sort of experiments can be modelled with the binomial distribution. We've looked at how to calculate things like this. When we have a random variable which is modelled with the binomial distribution, we can say what's the probability that that random variable takes the value 9, and we know that the way to do that is to use this formula. The only thing that we're missing is that at the moment we can only use, if you watch the first two videos that is, you can only do n choose r using the calculator n choose r function. So what we need to do now is find a way of finding this number. It can be written ncr or nr like that, as though it's written as though it's a vector. And we need to know how to calculate this number without a calculator. Now, or at least where this number comes from as well, all right? So what I'll do first of all is I'll show you this formula and show you sort of how unhelpful this formula is really. Let's say it's the number 10 choose 3. Well, 10 choose 3, it says here is that would be 10 factorial over 3 factorial times 7 factorial. So the first thing we need to know is what the factorial bit means. Well, that 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, well, fair enough. 3 factorial is 3 times 2 times 1. And 7 factorial is 7 times 6 times 5 times 4 and all the way down to 1. Okay, now you can perhaps see that this is already sort of useless, right? 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. If I'm trying to get an idea of how big this number should be, well, I've no idea of how big this number should be. So I'd just be typing this in the calculator, and the chances of me slipping somewhere is fairly high. So this is not a helpful formula, but if you look at it, there's a 7 on the top and a 7 on the bottom, so they could cancel out. The 6's could cancel out, the 5's could cancel out, the 4's could, the 3's could, the 2's could, the 1's could. So what I'm left with, when all that's gone, is 10 times 9 times 8 divided by 3 times 2 times 1. And that is something that I could maybe now estimate, right? 10 times 8 is 80 times 9, well, 9 times 80 is 720, 720 divided by 6. So, you know, that's a calculation that we can do in our heads. Even if the numbers aren't that easy, we should be able to get a rough idea. You know, we can just do this as 10 times 10 times 8, so about 800. 3 times 2 times 1 is 6, which is about 5, so 800 divided by 5, you know, we can work out roughly how big the answer should be. So, if we look at that, what's happened is, we started with 10, then we get 9 and 8, so there are 3 numbers written down on the top, and then it's 3 factorial on the bottom, and that's the way you should be thinking about these. So let's say it's 15 choose 4, start with the number 15, and then write down the next number is 14, then 13, and keep going until you've written down 4 numbers. So 1, 2, 3, 4 numbers. Times them all together, and that's the top. On the bottom of the fraction is 4 factorial, which is 4 times 3 times 2 times 1. Okay? That's how we calculate this. So just to rub it in a little bit, let's say 20 choose 6, start with 20. Write down the next few numbers, 19, 18, 17, keep going until you've got 6 numbers on the top. 1, 2, 3, 4. 6 numbers on the top. Times those together, divide by 6 factorial. Okay? And then from there, okay, with this one, it's still a bit tricky to work that out, but maybe we could do 18 and 6 and cancel that out and put 3. If we were trying to work this out without a calculator, we'd have some hope of being able to estimate the answer before we type the thing into the calculator. So that is how we find that number. 20 choose 6, 20 times 19 times 18. Keep going until you've got 6 numbers written down. Divide by 6 factorial. Okay? That's the idea. So, n choose r means if I've got n spaces, let's say there's 10 spaces there, and I'm going to pick 6 of them to be successes. So I'm going to pick 6 of these boxes to put a tick in. Let's say that one, that one, that one, that one, and then some of the ones in the middle. How many different ways are there of putting a tick in 6 boxes out of 10? Okay? That's the idea behind n choose r. The way we calculate that number is 10 times 9 times 8 times 7 times 6 times 5 times 4. Oh, no, it's not 10 times 9 times 8 times 7 times 6 times 5. 1, 2, 3, 4, 5, 6. There we go. That divided by 6 factorial. That would be 10 choose 6. That would be, if you've got 10 boxes and you're putting a tick in 6 of them, how many different arrangements are there of 6 boxes which have a tick in? Okay? Okay. So we know what 10 choose 6 means. We know what n choose r means. We know how to calculate it. All we need to do now is, why does this calculation give us the answer to that question? Now, I will do that in a separate video, because if I'm completely honest, if you don't know why n choose r is that number there, then it's not going to matter hugely. You can answer all the questions, but it is a good idea to know, because obviously there's a chapter in the core book and a chapter in the applied book, both of which rely on knowing what n choose r means. The chapter in the core book, by the way, is the binomial theorem chapter. And, you know, it'd be good if we know where these things come from. Strictly speaking, absolutely honestly, you can answer all the questions without knowing why this number gives me the answer to this question. How many ways are there of putting ticks in 6 boxes out of 10? But I'll put it in a separate video, and I would recommend that you do know it at some point. Just to reiterate one last point, that formula there, don't use that formula there. If you use it, you're going to get a big mess like this, which is pretty impossible. Think of that formula there as being shorthand for this process that I've outlined to you here, okay?